Hi, this video is going to be about right triangle trigonometry, specifically finding side lengths and angle measures of right triangles. So our first example, the directions say solve for x. If necessary, round your final answers to the nearest tenth. And so with right triangle trigonometry, recall that there were three trigonometric functions. We had the sine, which was equal, so the sine of our reference angle was equal to the opposite side divided by the hypotenuse. The cosine of an angle, so from our reference angle, is equal to the adjacent side divided by the hypotenuse, and the tangent of a reference angle is the opposite side divided by the adjacent. And so if we take a look at our right triangle, we have our reference angle, our angle of 58 degrees. That is provided to us. We know our right angle, and so the side across from the right angle is the hypotenuse. And the leg that is next to our reference angle, that is the adjacent side. So given our reference angle and the adjacent side and the hypotenuse, we're going to use the cosine ratio. So the cosine of our reference angle is equal to the adjacent side divided by the hypotenuse. And so if we substitute in, we have the cosine. Our reference angle is 58 degrees, so we're going to substitute in 58. And that is equivalent to the adjacent over the hypotenuse. So the adjacent side is unknown, so that's x, and the hypotenuse is 18. So now we have a basic equation, and we have a fraction. Now in order to eliminate a fraction in an equation, we can multiply both sides by the denominator. And so in this case, our denominator is 18. And so dividing by 18 and multiplying by 18 cancel each other out. And so we have 18 times the cosine of 58 is equivalent to x. Now that x is by itself, we can use a calculator to calculate this value. And so if we do that using our calculator, we're just going to type in our equation, 18 times the cosine of 58 degrees, closing the parentheses, and pressing enter. We can see that our side length, the adjacent side, is 9.5, rounding to the nearest tenth, units long. And so therefore, x is equivalent to 9.5. And so the adjacent side of our triangle, let me rewrite that, the adjacent side is 9.5. Our second question that we're going to look at, right? So again, we're given our reference angle. So starting from our reference angle, we have, again, from the across from the 90 degree angle is our hypotenuse. So I'll label that as HYP. And the side across from our reference angle is called the opposite side. And so we're going to use the sine function because we have the opposite side and the hypotenuse. So if we substitute in, so we have the sine, and then our reference angle is 40 degrees, so the sine of 40 is equivalent to the opposite side, and so in this case the opposite side is 12, divided by the hypotenuse, which is x. So now, similar to the last problem, in order to get rid of the fraction, we're going to multiply by the denominator. In this case, our denominator is x, so we multiply to both sides. And so on the right side, dividing by x and multiplying by x is going to cancel out. And so on the left side of our equation, we have x times the sine of 40 and that is equal to 12. Now, x is still not isolated by itself, so in order to get x by itself to undo multiplication, we are going to divide by the sine of 40 on both sides. And so multiplying by sine of 40 and dividing by sine of 40 will cancel out, and we are left with x equals 12 divided by the sine of 40. So now that x is by itself, we can use our calculator to evaluate that equation. And so typing in 12 divided by the cosine, I'm sorry, not the cosine, but the sine of 40, closing the parentheses. And if we evaluate on our calculator, rounding to the nearest tenth, our side length for the hypotenuse is equivalent to 18.7 units long. And so in this scenario, x, our hypotenuse, is 12.7. And again, I apologize, let me rewrite that. So x equals 12.7. Our third and final question, we are being asked to, in this scenario, we do not have the reference angle. We're told that is a variable, but we're still going to look at our triangle from that point, because that is the starting point, but we just don't know its value. And so the side across from that, value of 6, is the opposite side, and the side, or I should say the leg next to our reference angle, is the adjacent side. And so in order to calculate our angle, we have the opposite and the adjacent, and so that was the tangent function. So the tangent of our reference angle, opposite over adjacent. And so if we substitute in what we know, we have the tangent. In this case, our angle is unknown, so we're going to put x for our reference angle. The opposite side is 6, and the adjacent side is 7. So now that we have our equation set up, we're solving for the variable, in this case the angle measure. Anytime we are solving for an angle, we have to use what's called the inverse trig function. And so to undo the tangent function, we're going to use what's called the tangent inverse. And so we apply that to both sides. Now the tangent and tangent inverse operations undo one another. And so on the left-hand side, we will just have x. And on the right side, we're going to take the tangent inverse of 6/7. So now that x is by itself, we can use our calculator. And in order to use the inverse, on my calculator, I have to press the second button, and then above the tangent button says tangent inverse. I can enter in my ratio of 6 divided by 7 and close the parentheses, and I can see that my angle measure is 40.6 degrees rounded to the nearest tenth. And so in this scenario, x is equivalent to 40.6 degrees. Thank you for listening.